Okay.
Because what happened, it seems like that last Monday's that session not being recorded. That's why
Oh.
we missing that one. I mean, like something happened, internet got disconnected, and later on, when I restarted and reconnected, it seems
Mm-hmm.
like it didn't record anything. I think I don't know what happened to the previous section, but it seems like nothing has been recorded.
Okay.
Yeah, but you were there last Monday. In that day, you're not gonna miss anything like that. But when we continue that same discussion and with the where that I stopped that in chapter three, that I think pretty much we covered that. Do you have any question on chapter three? Do you get any chance to have a look at it, chapter three?
No, I have no questions right now.
Yeah, yeah, because that you didn't have a look at it. That's the key to success. Okay, okay. I understand. I know. I understand. That's okay. That because it's a lot of material actually. That you know that these every chapter has a 3.0 all the way to 3.10 all the time.
Oh,
Everything has like a 210. Yeah, almost like a 10 sections. But in chapter 10, what we're gonna do pretty much in chapter 1, what we did was that we were talking about the introduction. In the chapter 2, what we did was that how to collect data.
mm-hmm.
Chapter 3 pretty much and collect data, and sorry, that in chapter 1 we did the introduction plus the collecting data, how to collect data. In
Yes.
chapter 2 we were doing some kind of like a numerical measures, like for instance that then you have like a data set that you can talk about that just this the average, instead of go individually each and everybody's the GPA, let's say the income, heights,
Mm-hmm.
weight, kind of a thing, rather than going for individually, you're going to condense and say, hey, that I don't want to talk about this one individually, I can summarize. Those summary statistics are called that this mean median mode, those kind of a thing that you have seen even from the distribution too. So
Mm-hmm.
those things we talk about numerically how we're going to look at it. Then in chapter 3, pretty much what we did was that we built up for the given data how to just to display that given data graphically. Display graphically. That's what we did in chapter 3. Now
Okay.
in chapter 4, what we're going to do, we're going to see that that was that we were talking about all these variations and everything up to chapter 3, that only about one variable, one at a time. We were talking about one at a time, height. If you go to the height and then you drew the histogram for height.
Mm-hmm.
And then you drew that box plot for height. And you were looking for the mean of the height, median of the height. And the 5-number summaries. 5-number summaries means like a minimum value, quantile 1, quantile 2, or median, quantile 3, and the maximum. Those 5 numbers are called the 5 number summary. Those things that we normally that represented graphically only for one variable. But from now on in chapter 4, what we're trying to do is that we're going to look at one variable with respect to another variable, by another variable. That's what we plan to do over here, looking at how the one variable is going to vary over another variable. Let's say that heights, rather than simply say heights of that all that everybody in that data set. I'm going to say that by gender, male, female, like that, male
Okay.
side, female side, like that kind of a discussion. And that discussion can be built up that when you have like a quantitative data can be that explained by another quantitative variable, or quantitative variable can be explained by another categorical variable, like that. When you have another categorical variable by another categorical variable, or quantitative by quantitative, categorical, quantitative, and categorical. What that means that this pretty much, I'm going to share the screen in that way you can see what I'm talking about. This is what I'm talking about. Uh, so I'm talking about something. Hold on, let me get this book here. So I'm talking about like we have a two variables. Like let's say that you have a two variables. See, I can talk about this one too earlier, but I'm gonna little bit talk about it again. See, you have a one variable you're gonna put on x-axis. It's gonna be either quantitative or categorical. See, another variable you have, you're gonna put into either y-axis, but it's gonna be again quantitative or categorical. See? So the quantitative variable, like let's say for instance that height, you can talk about the height. See? Categorical, you can talk about the gender. See? See? So the here again that quantitative mean be you can talk about something like a weight. See? And categorical variable, you can say that again gender if you want. So no, not gender. We can talk about let's say another categorical variable like that height. We divided height into that rather than talking about the numbers of the heights that we just divided that into 3 parts like or 2 parts, short and tall, like that. That kind of a classification we can do that one. So especially that let's say that height, then if you get the height, you can talk about the height by gender. See, other variable. See, gender is a categorical variable. Height is what? Height is quantitative variable. See, quantitative variable. See, this quantitative variable being explained by the categorical variable for graphical representation. We're going to talk about over here. That's what we are planning to do. So that height can be explained through another. If you want, I'm going to put the gender over here. See, height can be explained through gender. See, like that. See? So if you want, height can be explained through the weight. See, height and weight relationship, you can check that one too. So those kind of that relationship between that different variables are explained 2 at a time by these in this chapter. Okay. So normally that's why they say examining the distribution of single variable is always an important starting place. But as data analysts, our interest usually go beyond exploring patterns of variation in a single variable. We want to explain the variation. In this section, we begin think about what it means to explain variation. We can start with an intuitive definition of explain. If you know someone's score on the one variable helps you to make slightly better guess about the person score on another variable. See, then we can say that the first variable explains some variation in the second variable. See, that's the same way. First variable. If you say that if you know the some kind of that male female based on that one, they can talk about that how they are the heights. All that different heights they can talk about, see, like that. That's what they say by looking at that one. So that kind of a discussion we're going to build up over here. If you go here, you see, let's get started by looking at the distribution of thumb. Write a code to draw a histogram of the thumb from the fingers data frame. Feel free to play around the features like the GF labels or with arguments like the color, fill, bin width. Can you remember that when we were drawing the histogram, what was the code to draw the histogram? Can you remember? If you want to get this one, can you remember how do you get this one? By getting the histogram. What are you supposed to do here? What do you put?
That I don't remember. Sorry.
Remember that GF, okay, can you remember GF, ggplot is coming from GG function. So see, G means like a GG function package already installed here. It has been loaded too because this book has already set up everything. So it has a function called, normally it is coming from GG formula. Can you remember GG formula? There's a GG formula package. From the package, we have so many functions called the GF histogram. Okay. That's the same thing that you really need to, that when you do the first homework one, you might need this one, histogram. Then what do you put? You're going to put the name of the variable. This is the name of the variable. See, I'm going to put the tilde for what reason? Tilde say that it's going to go to x-axis. If you write anything after tilde, it's going to go to x-axis. If you write anything before tilde, it's going to go to y-axis. So since I really need this one to go to x-axis, I'm going to write after that one. Then I'm going to record my data. Data name is what? Fingers. And if you want, as they say, that if you want that add the labels, some labels, if you want, you can add the labels. You don't have to worry about the same thing. Thumb length of student. If you want to say thumb length of student, I'm going to connect this one, okay, with the pipe operator. See, this is called the pipe operator. See, link operator, and then go with the labels now. I'm trying to put the label. See, GALBS, labels. See, labels, and put what? I'm going to put what? This one. See, can you remember that when you put them, the title? How do you put the title? What do you put the title? For the histogram, if you want to put the title, can you put the title here? GF label, see, and put that. See, you can say the title equals what? Say thumb length of student. Thumb length of student. Then you can give the color. Color gonna give you what? Color gonna give you the outside, that whatever the color. Let's say you're gonna give green color for that outline. And the fill, if you want, you can use the fill. Fill, just say that something blue or something, or gray color, doesn't matter. See, you want, see, look at it. And what other things that you can even use that x equals, let's say, you can say thumb is already there, then x already there. See, y label. If you want, you can change the y to frequency. See, see. Okay, this is how we do. See? Histogram. Put this one. You put the pipeline, the pipe operator or the link operator. Then labels go to put the title. What title you need? What color you need? Why the color doesn't come? Oh, I don't see the color. Is that capital? I think it looks like capital. Why color doesn't come? They don't have a green color or what? Yeah, the blue, because that's the outline. See? Color and fill. I put the. Why the color doesn't come? They don't have a green color or what? Let me see. I wanna see something. I'm gonna get this one and see chapter 3 and see which one. See. Let's go to chapter 3. We have a color. Various colors. We did this one. Visualizing the histogram. Okay. Chapter 3. Okay. Color. What color? Yeah. They get the green. Yeah. See. This one is just it's blue. Blue should come. But on this one, see. See, color green come. See. Color green should come. Let me see. I'm gonna do something. These two I'm gonna cut and here. color. Green, fill, blue. Okay, now this one. Yeah, see? It doesn't come when you put on the second one. It doesn't go with the labels. It's going to go only with the histogram. You see?
Okay.
Yeah, see, if you want to change the color, the color and the fill means like inside, okay? The color means like an outline, see, outline. So it has to go on this one. Before you're going to link that one, everything has to go over there. This is only for the labels only.
Okay.
Yeah, they're very, very particular because they're very, very picky, the machine. Yeah. He said that it's been the way they program that if you even miss like change that this case sensitive too, you cannot change anything. See, like that. You see, so you get this histogram. This is the way how you're gonna do the histogram for one variable. That's what they say. See, that's exactly the same thing we have. See.
Okay.
Yeah, is it? That's the way how you can do. See, this is the way you're gonna draw the histogram and then add the title. And if you want, you can change the Y label. X label, they're going to take it from here, definitely. See? You don't have to put X and then do the label again. Make sure you're going to write all the strings, all the characters within double, low, single, inverted commas. Okay. So you got that one. So then we see. So we have seen this distribution few times now. It looks like most of the thumb runs between 40 and 80 millimeters. See? 40 to 8. See? Most of them. See? 40 to 80. The center of the distribution is somewhere around 60. See, center is somewhere around 60. That's true. And the distribution is kind of bell shape. See, bell shape. If you get a smooth curve on that one, it looks like a bell shape too. See, we talk about the shapes. And with most of the observation clustered around the middle, most of the observation clustered around the middle, then just a few observations of the see, outer tails. Let's say we want to use some other variable to explain the variation we see in the thumb length. A certain place to think about the variable, that is, if you know someone's score on the variable, would help us to make a better guess about their thumb length. See? Below is a list of few of the variables in fingers and description of how they were coded. Which of these variables might be associated with thumb length? Which one? Let's say. See? This one, gender, 1, male, female, 3, prefer not to answer, race, ethnic, white, African American, Asian, Latino, others. Year, first year, second, third, fourth, other. Math anxious, agreeing with the statement. In general, I tend to feel very anxious about mathematics, strongly agree, neither, agree, no, not disagree, blah, 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 that. Then grade point average, predict ring length in the millimeter from the tip of ring finger to the crease between the ring finger and hand, see? Height and the weight, those things. So out of all these, that we can figure out that which one gonna get. You can kind of like a guess and see that which one would gonna go with the thumb length. Thumb length is affected by gender. See, you know that male fingers and female fingers not gonna be look the same. Okay, so because of the race, ethnic group, see, ethnicity, see. It's gonna be, see, because of the ring finger, see, height, weight, everything gonna affect to that one. See, that's why they were saying that below is a list of few of the variables like that. Okay, Brick, we just started. Okay, we just started chapter 4. Okay, everything's been recorded too. We just started. I'm on 4.1. I was explaining that in chapter 4 that we are talking about that. If I'm gonna go back to it, it started. We were talking about that just to that how to in the very beginning, chapter 3 up to chapter 3, we were talking about one variable, variation of one variable. That means distribution of one variable. That means graphical representation of one variable. That means histogram of one variable, or smooth curve of one variable. Up to that point, just one variable, like the way that we see over here. This is about a thumb length. See, the variation of that one, which is called the distribution, see, and the graphical representation of distribution is the histogram. Then if you get the smooth curve by looking at the smooth curve scheme in the top of this one, that would be your distribution, statistical distribution. It has a shape. It looks like a bell shape, see, symmetric. See, most of the that data being, see, they collect over here, see. They were going to be over there, see, centered around that one, see, clustered around that, see, this point is the same thing. Okay, sorry, the same thing. See, clustered around this one. See, so that means like your mean, median, mode, pretty much three of them because of the bell shape, because of the way that I explained earlier, the bell shape, that pretty much everything's going to be at the same place. And there are some, see, unusual observation note aside too. See, those are like kind of like sometimes outliers. Sometimes you can get rid of them. You know how to get rid of. See, truncate them. We know pretty much how to filter data, those things like that. Now I'm talking about that they were telling that this explanation just not enough. They want to explain the thumb length by another variable. That's why they were thinking about which variable they might going to pick out of these variables that's going to be available in this finger data set. Fingers data set, there are so many variables. We were talking about the thumb length. In addition to thumb length, excuse me, we have so many other variables that might gonna just can be very helpful to explain the thumb length of the individual. So they were just asking us that below is a list of the few other variables in fingers data set and description of how they were coded. Which of these variables might be associated with the thumb length? See, thumb length might gonna be changed, see, different according to the gender, ethnicity, because of the ring finger, okay, and the height, weight, and all these things, okay. So that's why they were thinking, instead of doing that one, see, you're gonna explain the thumb length by gender, see, by gender. See, this is how we're gonna do that one. See, they've been stacked on top of each other. See, this one male for this color, this for the female. So now we're not gonna do this one by hand. We don't have to worry about that. That's why this programming is so powerful. If you go ahead and look at the code, you can easily see, get the histogram. You're gonna do the thumb and data. Instead of for the fill, rather than put in a color, you put the gender, the variable that what you are interested in. In the beginning, I'm using a categorical variable. This is quantitative variable. You see, quantitative variable has been explained by a categorical variable. See, look at that. In the beginning, for the fill, I put a name of a color. See, fill, I put the blue color to fill this in. They say, fill this in using that gender. See, that's the code. See, that's how you're going to do that. And if you want to stack on top of each other, this is the code. Go to the variable that this one. On y-axis, you're going to get the count. Here you get the thumb length for male and female, and they're going to show the legend over here very easily. You can get those are with their own colors. Even these colors can be just customized, and then you can change it later. Okay, you can change it later if you want. But for time being, they're going to by default they're going to give these two colors. See? Look at this one. Pretty much the same way. The data, fingers, fill. You put the gender, and you see. You're gonna refine scale, fill, manual value. See, you're gonna give the purple and orange. See, see, you can do like that. See, see, you can change to purple and orange. See, that one. These are given by the default. Now you're gonna by giving this code. See, scale, fill, manual. Manually you're gonna do this one. Give the values. See, purple and orange. See, those two. See, you change that. Not only that, instead of doing this stacking, you can get this one to the side, either horizontally or vertically. See, horizontally or vertically, you're going to separate. You take that out. You're going to look at the male height and female height separately, rather than having them stack on each other. See, like here. So this one, you're going to do by just, see, go to this one, thumb, data, fingers, that's right. Let's say that we're not going to talk about the making that one fancy. And put this pipe operator, and then go to the facet grid. See, GF, see, underscore facet underscore grid. See, dot. See, as I said that this that means gender gonna go to the x-axis. See, gender gonna go to x-axis. That's why it has been written after tilde. And you're gonna fill in what? See, this one for the first row. See, within the row. This is like a row. This is like a gender gonna go to column, see? This column and that column. If you switch this one and then put the other way around, see? Other way around, look at. I put this one first, see? That means that before tilde, you have the gender. Before tilde you have a gender means you are trying to get the gender in the y-axis. See, y-axis. And that this means like you're gonna get the gender into y-axis. This means you are fix the column. You fix the column. See, that means everything's gonna go column wise. That means you do the changes row for the rows. See, as a column. See, go through the columns. That means you have arranged this one vertically. See, vertically as a like a facet grid. See, this one as a facet grid, or this one again horizontally has a facet grid, or stack one. And then it will show you that how they're going to vary. They are averages, how their variation. Look at the maximum value. See, has peak. Not that many people. See. So that would that be here that sometimes at around 60. See, this one sometimes around 65 or something like that. See, right. This for female, this one. Okay, so they have thumb length difference. You can easily see. They say they try to compare the two distribution number. Do thumb lengths vary by gender? Yes. See, like that. Here even you can compare and contrast by looking graphically. This is the code. See, this is the code. You're going to draw the histogram and then put the type operator and use the GF facet grid to get this one. To get the stack one, you're going to use this one that we used here. For the fill, you're going to use this guy, gender. It has been given by gender. If you want, you can put another categorical variable. So you have a quantitative variable being explained by another categorical variable. See? Then you want to change the colors. See? Custom colors. See? Purple and orange. Right there. See? Change the default colors for the different value of the explanatory variable. See? That's why they say. GF. Instead of getting that histogram, we're going to get the density histogram, thumb, data, fingers, fill has been done. See, fill or color. Even that's why they say you can use even the fill argument. See, even for the fill you can use that one. See, you can use that one. See. Okay, now we're gonna use what? We're gonna get this part. See, that's the same thing. See. Okay. And then you get this one greater than this guy. And purple orange. See. Change the default colors for the different values of the explanatory variable. This one. Let's say you're gonna get the same thing. So we still get the purple and orange. Why is that? Let me see. Okay. Histogram, thumbnail, these are the by default ones. Why it's not gonna change? That's the mistake. Histogram, thumb, data, fingers, fill. Okay. Scale, fill, manual. Value is gonna be new value is gonna be see purple and orange. 1, 2, 3. Open, 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 close, close, close. To change in the fill colors, use the different values of female and male in this histogram we made before. See what is that? Let me see. Yeah, why this one doesn't work? Same thing. Put the dehistogram run again. Doesn't matter. It's okay. You change the color, see, then it's going to show even the see, legend over here. See? So if you want this one, like that facet grid, see, say that let's say regular one, instead of stacking, you're going to get that to the sides. So you're going to do the change. You're not going to stack. You don't need this part. Let's see another one too. I want to say with this one, okay, this has been done with the fill, okay? This has been done with the fill. That means that they are filling inside for the male and female separately with the different colors. Let's say that, for instance, instead of that one, I'm going to use here, instead of fill, I'm going to use color. Color for the normally in the histogram, color for the outline color. Let's say that outline color has been utilized in order to separate the male and female. See, look at now. Outline color has been utilized to separate male and female. See, look at that. You can either use the color or fill. Okay. Then let's say that, yeah, that one. Then if you want to change the color, see, you can change to purple and orange. Let's see why it's not going to come with the purple and orange. Why we cannot change that too? So the previous one means this is for that. When you separate them with the see inside fill color, this is separated by the outline color. But even with this one, okay, this is not gonna work with that one. No, don't need that one. Without that one, see, still you're gonna get it. See, like that. Because of that, you are using this one to separate them rather than the color. See, this one for you can use that one too. And on the other hand, as I said over here, that you can just take them out and then see how they vary. By that, the heights vary by thumb length vary by the this gender. So you wanna do this one, see, X. You're gonna put that gender X. That means you are doing this way, horizontally. But you have to make sure you're gonna say for the first one, see, you're gonna make it fix. See, put a dot to make it fix. That means your row is fixed. Row is fixed. Okay. See, your row. See, row fix this way. In the one row, you're gonna have male and female separate. See, they were separated. Then you can give the colors and everything for them. Okay. That's what you see here. So if instead of that one, if you want that to happen vertically, to pretty much the same thing, see, that we are using that command, gef facet grid, okay, gef underscore facet dot underscore grid. Here, another function, p underscore, which we refine, okay, the histogram, see, like that. So here that if you go to histogram, then thumb, data, fingers, then facet grid, you see, I'm going to write that one Y, see, that means vertically. If you do that one vertically, you have to make sure you fix that vertically. That means the column has to be fixed, see, within the column, see, this is the column. They've been written, see, on Y-axis, see, like that. See, that kind of that explained that has been explained through that one. See, modify the code to create a density. See, histogram. That's the same thing. See, modify code to create a density histogram. Only thing that you have to put a D. See, D modify. See, it's been done. See, it has to be vertically. See. That's one. So the same way, see, where would you like the histogram to notice within group variation, the spread of the distribution? Within group, see, within the group, see, look at it. If you go to within the group, this is called, see, within the group you can see the variation. Within the group, within that female group, within male group, you can see the variation, see, like that. So mainly that one. Then on the other hand, then again, that we can just see, play out some kind of a smooth curve, see, scheme in the top of that one, see. You have this one, see, histogram. At the same time, you can give that one to both of them, see, by this function, see, GF density function. This is from the facet grid. How you want to do the facet grid, vertically or horizontally, you better decide that one, either this way or vertically, the way that we have done over here. It has been written in front of tilde. That means you have to have a gender, whatever they have for the gender, that male and female, those labels, those are called the classes, gonna go vertically, male and female. We will figure out male and female and gonna be distributing vertically this way. Okay, like that. See, number of beans. If you want, you can add the beans. So many things you can do. See, now you're gonna add this density plot. See. And you can chain on the density plot. See, it's a density plot. It looks like this. See, it has so many, see, ripples over here. See, kind of like a, see, one peak. See, here one peak is kind of like a smooth. We can get a very smooth curve later on. We're gonna show you that how to get a smooth curve scheme in that one. This is not a smooth curve. See, this is just the density curve. See, density plot or density curve. You can get that one by adding this one. See? Then they're talking about the colors. See? Give the colors and then do this grid. See? Colors you can change, fill, orange and color gray. Color means like outline. And at the same time it has been done, they were separately displayed. Male and female thumb length are displayed using their respective histogram vertically. See, this I call the GEF. You know, GF stands for the GG, that formula, and then it's coming from that. We say that it's coming from that package. This is the function. See, here same thing. This is the function. You can change the colors. See, look at this one. You have learned to make some pretty fancy histogram now. Let's take a moment to reflect. What kind of a variable should go in GF facet grid? GF facet grid, what kind of a variable? See, if it's a facet grid, always inside that one, gonna go, see, categorical variable. See, categorical variable. If it is a facet grid, facet this function, then you put the categorical variable here. If it is a histogram function, you put what? Quantitative variable here. Histogram are for quantitative variables. Tallies are for categorical variables. Tally you can use for the categorical or numerical, both. Okay, it doesn't matter. Actually, that you can use for both. It depends on, okay, because sometimes even the numerical numbers, like let's say the heights, the two people height is going to be the same. In that you can say that that particular height has occurred how many times for going to be checked with the tally. But that's okay. Most of the time, they use that categorical variable. So inside the histogram is for quantitative variable. So this facet one, see, we're going to do that one by this being separated by, given that stack histogram being separated by this particular categorical variable. See? Then see, we can do the same thing for another kind of a see, categorical variable. See, by ear now, facet grid. See, again this one has been given through the way ethnicity, through the ethnicity, but everything has been done vertically. See right there. So by year, see, we relate from this one. See, look at this one. Okay, let's see that histogram. See, histogram for different ethnic groups. See, and by the year, that which year you're gonna be there. First year, second year, third year, fourth year. See, for that one, for their histograms. That for this one. See, this is categorical. This is numerical or quantitative. Again, quantitative, race ethnic, categorical. But it has been done vertically. That's why y-axis. On the y-axis, you have all the classes of race ethnic. Within the race ethnic, you see several classes. See, 1, 2, 3, 4, 5. White, African American, Asian, Latino, and others. In here, the same way categorical. 1, first year, second, 2, 3, 4. Even though we have numbers, those numbers not like a numerical numbers. There's nothing going to be that makes sense that if you're going to just simply add this one and multiply and then divide, subtract, you can simply that make this one as a label. See, there's a factor. See, categorical. Like that. Of the two variables used to create the factor, the facet histogram about year in college and the race, and which does the better job predicting the thumb length. See, this one, look at this distribution. You're not going to see anything very clearly. Some when it comes to the fourth, it seems like there are no people available, see, to get this information. See, see. So, but here, see, by looking at how they distribute, see, distribution, variation, see, thumb length variation can be figured out that by at the different ethnicity, people's ethnicity. Right there. Okay. Keep going. See. Then at this stage, I'm going to introduce something called the outcome and explanatory variable. Outcome and explanatory variable is the same thing that we discussed so far, but it's in a different name. Okay. Okay. That means we have, see, whatever gonna go to x-axis. I'm sorry. I'm gonna connect this one. Okay. So I'm gonna talking about this one. Up to chapter 3, we were talking about only one variable. See, this is one variable on x-axis. Now in chapter 4, as I mentioned in the very beginning, we're going to talk about the two variables. We're going to talk about the variation of one variable by another variable. That's the discussion over here. So whatever going to go to x-axis, we're going to call that one explanatory variable. Explanatory variable. Sometimes we call the regressor variable. Sometimes called the regressor variable. Sometimes we're going to call this one an independent variable. Independent variable. See, right there. But for y, see, on the y you're going to have the variable called the outcome variable. See? Outcome variable. See? You can say response variable. Sometimes we call response variable. Dependent variable. See? So in our discussion, these two, then we're going to say what type of variable going to go to x-axis, what type of variable going to go to y-axis. Mainly we have two types, okay, all discussion, as I mentioned in the very beginning, we have quantitative data and categorical data. That's it, we have two types. Let's say that now out of these two, which type going to go to x-axis and which type going to go to y-axis. So both can go to x-axis, so and both types can go to y-axis. Or vice versa. We can double check and see how it's going to work. So sometimes they call this one another name regressed variable. Regress variable too. Regressed. So this is that kind of a discussion we're going to build up over here. So I'm going to say that my x, see, is my explanatory variable. That's the explanatory variable. Okay. So here, this is my y. Y would be my outcome variable. Then explanatory variable may be what? The quantitative or categorical. See? So does with this one. Quantitative, quant or cat. If you have that y variable, outcome, quantitative, being explained by another quantitative variable on x-axis, we're going to have something called a regression. That's what we are heading. Okay, regression. Okay. Then if the y variable is quantitative, but your explanatory variable is this one, then we're going to say group regression. See, that's a group regression. We can call the group regression for family. Or we have another name for this one, analysis of variance. Analysis of variance means I'm going to abbreviate this one or acronym that one as ANOVA, analysis of variance. Now for the y-axis, you have a categorical data, but for the x-axis, you have quantitative data. Then you're going to have something called logistic regression. We don't do that one. Logistic regression. Then for both cases, you have a categorical and categorical. Then you're going to use something called the chi-square test. So mainly in this whole situation, in this class, we're going to talk about this guy. That's what we are trying to do. In next class, we're going to talk about this guy, 605. In this class that we're going to cover all the way up to chapter 7, start in chapter 8, 9, 10, 11, will be covered in next class. So in this class, this is what we're going to cover. See? That's what we're going to cover. The group regression. That's what they are trying to build up that kind of a discussion. So that's why they say that we have two variables, and the variables are now they're going to call with the different names, outcome variable, and so you see outcome and explanatory variable. See? In my example about something that we now have the sense of what it means explain variation in one variable and a variable in another. See, variation in another. In the previous section, for example, we saw that the variation in thumb length could be explained in part by variation in sex. Okay, in this section, we want to begin developing a language to describing the variable that play different roles in these relationships. Relationships in which one variable explain the variation in another variable. Yeah. We're going to see when you're going to do some kind of for this one, that if I'm going to add to this one something, you can see, you can talk about that categorical variable that like a gender, quantitative variable, you can say the height. See, even for the that y variable, you can put another one, that weight. This categorical variable, you can think about that the categorical variable. Let's say this gender has been utilized over here. Ethnicity, see, ethnicity or something like that. As an example, you can think about this is height, this is gender. Okay, like that. Then this one you can talk about the weight. You can talk about this one ethnicity. See, like that. As an example. Then you can check and see the height, how the height and weight are related. See, how the okay. What I'm gonna do, I prefer to put this here. Okay, a little bit of this one, and I prefer to put this way. I'm gonna go ahead and put for this example, I put weight. For x-axis, I put weight. So that's for the, and then yeah, for the weight, and this one height. Yeah, height like that, or it doesn't matter. Doesn't matter. See, those are kind of like the height and weight relationship, and height and gender relationship. How that can be. See, how the height can be explained by gender. How height can be explained by weight. How ethnicity. See, being explained by this way, or whatever based on the given example. Okay, then gender and then ethnicity, how they can be just to see that how they are related to each other. Okay, so that's why they say in our exam. See, so when we were talking about the relationships, and then we're gonna not only that, we're gonna down the road we check that how closely or how strongly they are related. Okay, that's kind of a discussion we built up to. Up to this point, we have distinguished between categorical variable and quantitative variable. There are only mainly two variables. But our desire to explain variation in one variable with one other variable lead us to make another distinction, that is between outcome variable and this one. That means like mainly those are the names. You're gonna say that whatever gonna go to the x-axis explanatory variable, whatever gonna go to the y-axis outcome variable, but they have their type. Their type would be quantitative or categorical. Quantitative or categorical. Doesn't matter. Together, quantitative or categorical, regardless it's being quantitative or categorical, if that particular variable gonna be placed on x-axis, we call the explanatory variable. That's the independent variable. It's gonna change independently. When with the changes of that variable gonna affect to the changes in the other variable, outcome variable. See? So that's why they were asking here in our example thumb length and gender, which is the outcome variable. See, thumb is the outcome variable. It's been explained by what? See, explanatory variable. See, there are more names for the outcome variable, as I said earlier. Explanatory variable, independent, predictor, treatment, experimental, factor, more names. See? For this one, you have more names: dependent, predicted, response, output. See? Those 1 million pretty much same thing. Okay. So that if you go ahead and then look at this one and see that two variables you're going to take into account here. See? Look at here. In the mindset meta data frame, we have results of an experiment where researcher informed randomly chosen group of housekeepers, 41 of them, that the work they do satisfy the Surgeon General's recommendation for an active lifestyle, which is true. They were also given an example to illustrate why their work is considered good exercise. The others, 34 housekeepers, were told nothing. One group gonna go to like control group. Control group, you're not gonna tell them that this gonna be a good exercise for your health or something like that. But one group, they're gonna explain to them and say that whatever the work that you do would constitute a kind of like a good that exercise for your good health. So, see, whether that individual housekeeper was informed or not was recorded in the variable called condition. Condition means whether they've been informed or not informed. See, categorical. The researcher also recorded whether each housekeeper lost weight or not. After 4 weeks in categorical variable called WTC, weight lost, either lost or not lost. The first 6 rows of the data frame for these two variables are shown below. See, you can call two variables at the same time. See, you go to the data set. See, you select them first. See, this is a function. Select. In order to select, you have to go to this guy, data set, data frame, variable, and you're going to read the first 6. That's how you put head. Open, open, close, close, and you get this one. Which of these two variable is the outcome variable? Out of these two, which variable would be the outcome? See, look at here. Now, as I mentioned here, you are talking about two categorical variables. This is the case. This is the case they were talking about here, kind of see. But mainly that's kind of a thing that we don't do too much, but we have barely mentioned that one. Actually, that barely, that even that I mentioned that this is the major topic in this one, Now in this case that they were talking about this one there, see, categorical to categorical, see. Categorical being explained by categorical. X-axis and y-axis both being categorical, see. It doesn't matter, but once you get these two, we have to figure out which one's going to go to the independent variable, which one's going to go to dependent variable. Out of these two variables, both are categorical. Which one's going to be independently changed, whether they've been informed or not? Based on that one, your weight loss, see, see, they think like a being informed or not, that then you can check the weight loss. See, which of these two variables are outcome variable? Outcome should be definitely the weight lost. It's not the weight income. It's not the result. This is the result, whether you have lost weight or not. It's not. It is based on whether you've been informed or not. Okay. So this is the outcome variable. See, outcome variable. So this is gonna be your explanatory variable. See, write some code to examine the distribution of the outcome variable. See, write the code to make the most appropriate visualization for the outcome variable. How do you do that? See, weight lost. I'm not talking about two variables. I'm talking about just one variable. Okay, I'm focusing on my what? My outcome variable. For time being, they say, hey, write the code to display your outcome variable, which is a categorical variable. If it is a categorical variable, you definitely, the single categorical variable, what are you supposed to do? If it is a quantitative variable, I think single, okay, single variable. I'm talking about single variable. Yeah, single variable. For quantitative variable, how do you display that the graphical representation is nothing but GF histogram, see? Histogram tilde. You're going to put what here? You're going to put the quantitative variable, whatever the quant variable, comma, data. If you have a categorical variable, then you're going to go and get the bar graph, no? Bar graph, see? You can put here categorical variable, cat variable, bar, comma, data. You can remember that we did that one in chapter 3. See, chapter 3 we did that one. See, I'm going to show you that visualizing. See? So 3, see the visualization distribution histogram. Then the 5 number summary is fine. That 5 summary GDP. Yeah, we did the box plot. No, sorry, not the bar graph. Yeah, here. So, see. Categorical variables, see here. It should be just a bar. I'm sorry, this here. This one just a bar only. You don't need the bar. As for single variable, see, it's gonna show you this like this. That's what they are trying to do over here. That's why they say that if I'm gonna get this one, copy and paste. Copy and see, they were talking about go to do weight loss. That's the way outcome variable. Get this one. It's one variable, okay? Don't worry about that, whether it's going to be outcome explanatory. There's no such discussion here. Whatever you have picked like outcome variable, now you're going to consider like a one variable. That is the weight lost, okay? So WT, weight lost. It's going to go to x-axis, okay? If it is x and y both are considered, it's going to go to y-axis. But it is singly considered, it's going to go to now x-axis, okay? Follow very carefully, okay? It is coming from mindset matters, no? see. Weight lost, count, see. Lost, not lost, see. See. Around like 40, 47 or something like that. This time I put this one on a y-axis, okay? Make sure I'm drawing the bar graph for one variable. That's why they say whatever they ask us to do, I'm just doing, okay? But when it comes to two variables, these two, if you find some kind of a connection between these two, categorical and categorical, then this gonna go to y-axis, this gonna go to x-axis. That's a different thing. Can you draw that graph between these two? Yes. Can you do some kind of mathematical analysis? Yes. At this stage, we are just talking about only graphical representation only. We're talking about the graphs only. We saw earlier categorical quantitative data, which is our thumb length, quantitative by the same picture. I'm talking about this same thing, okay? This is for the processors. For this one, if I draw this one again over here to give you some kind of a idea one more time with the graph. Now with the graph, that's the processors. So this is your, let's say this is your explanatory variable, okay? It's an explanatory variable. Here you have y, which is outcome. Okay? It's gonna be the count or categorical variable. This one is the count or categorical, okay? What I did was in the earlier, this quantitative variable, okay, quantitative variable being explained by the categorical variable. See, this one I did. See, this is the one I did with the word. So not for the first one I did, yeah, quantitative y being explained by the categorical. This one, like let's say that we did the graph, three graph we did over here. What are the three graphs? See, stack, histogram, I did. The second one I did facet grid. See, I did vertical one. And third one, facet grid, horizontal one as well. See, I did all these. You can remember. That means that when a y for the y, I use the thumb length, and for the categorical, I use the gender. See, for this one. See. Now here we have a categorical and categorical. See, another setting over here. See, categorical and categorical. See, categorical and categorical. This is going to go to y-axis. This is going to go to x-axis. But we forget about without going to connection between these two. We just pick that whatever you're going to call as a y variable or independent variable or outcome variable. For that guy, they ask us to draw the histogram. Sorry, bar graph. See, like that. See, now they say that use a facet grid. See, can you use a facet grid at any plot, not just histogram? Try to create in a bar graph with the weight lost, but chain on a facet grid to compare the outcome across conditions. See, we can still do that one too. See, look at what's going to happen. Now, I'm trying to do the graph for between cat and cat. For that one, can I do the stacking? I don't do the stack one. I can do the facet grid. Yes, facet grid. Horizontal, I'm going to put H for that one. Second one, facet grid, vertical Z. See, can I do those two? Yes. See? Yes. That's why they say to do that one. See? See? How could you going to do that one? See? First you have to get what? Bar graph, and then see, then link, see, but chain on a facet grid to compare the outcome across the condition. Now it has to be done by the condition. You can remember how we did this one. See, for the for the quantitative and categorical, how we did that one. For the thumb length by gender, you can remember. Now this time, weight lost Yes or no? Weight loss means like how, not how much, okay? Not how much. Weight loss, yes or no? That's why I'm calling the word categorical. Being explained through whether they've been informed or not. Then we can we draw some kind of a bar graph? Yes, because of the categorical data, you definitely, because of your outcome is categorical, you have to definitely draw the bar graph. Here, since that your quantitative variable, sorry, the y outcome variable is quantitative, you definitely have to draw the histogram. It's not enough. That histogram can be stacked by gender? Yes. Can you draw the facet grid by gender? Yes. Can you draw like a facet grid by gender, horizontally, vertically? Yes. Here, again, this outcome variable is here, the weight lost. Can we explain that one through whether they've been informed or not? Yes, vertically and horizontally. So can you remember the code? What's the code? See, you can remember the code. What are you going to do? See, you go to that, the previous one, for my convenience, I'm going to copy and paste, okay? So, see, the halfway through this one, I'm talking about this guy, okay? This guy, see, okay, let's get this one. And then do the necessary adjustment in order to that fitting into what our discussion. Our discussion is between categorical and categorical, okay? Outcome variable categorical, explanatory variable also categorical. See, how to make a most appropriate this that we did that one. So this one, so to get this guy. So in order to get this one, create a bar graph of weight lost. Then use the GF facet grid to compare the outcome. Okay. So this one gonna be bar graph has been drawn to weight lost. Weight lost. Bar graph has been, okay? Bar graph has been, see, drawn into facet grid. So that's why I'm gonna put to x-axis. Don't put to, you don't have to put y. It's gonna go to, see, weight loss gonna go to x-axis. X. If you want, you can put to the y-axis. It doesn't matter, but this is gonna be, but for your convenience, I'm gonna put this one to x. See, it's on x-axis. Remember that this has to go to, this is the way that we say that this is the outcome. Okay, don't get confused here. Weight loss has to go to the y-axis. And whether they've been informed or not should go to here. See? So we can do like that way too. But they have flipped that one for their convenience, okay? So that means that whether they've been informed or not, see, you can put to the x-axis too. Here they are doing the y vertically, okay? But all the time, when you draw the bar graph or histogram, whether they've been outcome variable or explanatory variable, doesn't matter. It has to go to what? See, x-axis, the way that we are seeing over here. So your data would be mind set matters. And then go to grid, see, facet grid by what? By condition. Condition. Okay. It has to be done, see. Why? Because of that, I'm going to change this one too, okay? So, has to be drawn. See, tilde has to go here. Tilde has to go here vertically, then dot. Let me see. Did we miss something? Okay, mine set facet grid condition. If paragraph weight lost. Okay, this one right. Mindset matters. Let me see how to spell that. Yes, the mindset matters. Okay. Condition. Conditions. No. Cross condition. Condition gonna go this way. Why? Mindset matters. Facet fit. GF. Okay, no. Get this one out. Let's see. I wanna see some. Okay. Then connect. What is capital? I'm sorry. Condition. No, not the conditions. Not the capital. Condition. See, yeah, see. Anywhere you don't see that label here, like a weight loss, you don't see the condition, and there are two labels, see, two classes, whether being informed or not informed. But the weight loss has been done this way. You draw the bar graph by having that whatever the desired variable. See, you're going to draw the bar graph for this guy. It has to go to the x-axis. It's being explained by the another variable. Okay, another variable. Okay, let's say that you're going to put this one to dot tilde. Okay, dot, forget this one. See, weight loss term. Still go over here because of the way that we have done this one. See, weight loss. And for this one, within that one, you're going to show that whether lost or not lost, not lost. See? Now horizontally, make it like a facet grid. See? So we did this one for like a categorical to categorical. See, categorical being explained by the categorical. See? But first you have to make sure what kind of a graph you really need to gonna do that one for individual variable, whether it's the outcome or it doesn't matter. It has to be, you draw the bar graph for this guy. This guy being explained by the other guy. This guy, that's why we call the outcome variable. This is outcome variable. See, outcome variable. Normally outcome variable gonna go to, look at this one. Look at this one, whether this gonna work. Okay, let's see. I'm gonna put the tilde here. See, doesn't work for that one because that if you want change this one, tilde and dot. Doesn't go like that. See? Weight loss, if you put here, you have to put condition here. See? Why condition? See, another way of doing this one. See, another condition. Let's take this out and see what you're gonna have. Okay. See? So the bar graph, it doesn't work. See? So it doesn't work. So it has to put onto that x-axis. See? X-axis, x, see, whatever the variable that you are interested in to graphically represent, going to go to x-axis, and it's being explained by the other variable. You can put vertically or horizontally. That's a different thing. See? Condition. You can do this way or the other way. And now you can check the tally. See, weight lost by condition. See, look at. This is the weight loss by condition. This is the thing. Contingency table, condition, and weight loss. All the information you can get. And for the, not the number, how many people, informed people have like a weight lost. How many are people uninformed got a weight lost, like that. Instead of that one, you go to the proportion. See, this is a command. Weight lost. been explained by condition. See, condition gonna go to X. This is Y. As I said, this is the same thing. See, if whatever you put to X, see, it's the contingency table. See, X. See, we're gonna put the whatever that variable, one variable. See, I'm talking about is this another one I'm talking about. There's come something like that here. That now you pick only one variable. See. So see, here we have that condition, see, condition, condition, condition which is going to go to x-axis, see, condition going to go to x-axis, see, whether they be inform or not inform, see, uninform, now it has two, see, inform, inform, uninform. This one, this condition is categorical, see, and here we have the condition means x variable, see, this another way we call the explanatory variable, see, explanatory variable which is x, which is type wise is going to be categorical. It's a y means like outcome variable, see, it has a two parts, okay, what are the two parts, whether you're going to get, let's see, wait, last or not, see, last or not last, last or not last, see, whatever the one variable, okay, here I'm talking about different thing, okay, on the top one, that explanation different. Here get the one variable, that variable has several levels, and get the one y variable. I'm in the top the table. I'm talking about whether it's going to be quantitative or qualitative. Here again, y become count. See, count. In another way, I'm inside this box. I'm talking about when I'm inside the box, this box, when explanatory variable being categorical and then outcome variable being categorical, that will be more elaboratively that explained by this table called the contingency table. How do you get the contingency table values? By running that tally, okay, or sometimes we call this one confusion matrix. And here, see, confusion matrix, another name for that one is confusion matrix. Even for that one, you can get what? What you can get? You can easily get, see, there, see. So this is this explanatory variable. In our case, it's gonna be condition, okay, condition. I'm gonna draw this one more time, condition. This one outcome. That one is weight lost, okay, whether it's lost or not, okay. Here, yes, no, something like that. Here, condition inform, yes, no, inform, not inform. See, another way, yes, no. See, then you can get their totals. How many people that who've been informed lose the weight? That number you can put here. You can put that number here. This number here based on that one. Then you can get a total. These are called the marginal total. Marginal total. Normally this one called the row total. See? Row total. So you're going to add this one to this side, this number to this side, and these are called the column marginals, column totals. They can add this way. Then at this box you're going to have the grand total. Grand total. That's what we call the contingency table or confusion matrix. That's what they're going to show over here. See, you can add this way. See? You're going to get the row total. See, row wise. How many people lost weight? See? You can get one shot. How many people not lost weight? How many people been informed? How many people not been informed like that? And how many people participate in the survey? Gonna be the grand total or grand proportion. Doesn't matter, proportion wise or number wise or doesn't matter. See, it's like that same concept we're gonna utilize in that whether that you know that if you sometimes that you're gonna take some kind of a medication for certain thing, that oh go to a medical doctor and then he say based on some kind of a test, some patient being identified as a healthy or diseased, then they're gonna go to the second test. Again, healthy or diseased. Sometimes deceased person being not identified as a healthy, deceased at the second one, and deceased being identified as healthy, or vice versa, or the deceased being identified deceased. That's right. Yes, yes, okay. And the no being identified like yes, see, something wrong over there. Somebody that not deceased being identified as deceased. See? So we're going to talk about those things down the road. Those are errors. See? Like the error, see, here we can say yes, yes, okay, no, no, okay. These two blocks, so these are called the cell. This cell and this cell, okay, that's a correct decision. But something not being identified as what? Yes means like a something wrong here. That's called a very erroneous that decision. See, and so does it this one. Those are called type 1 error, type 2 error down the road. Okay? But anyhow, at this stage, this one that we are trying to graphically represent it. We now have explored example of three of the following kinds of variables. Which have we not yet explored? Categorical outcome. Did we explain? Yes. Categorical outcome. Did I explain? Yes. Categorical outcome. That's why we use the facet grid bar graph. Facet grid bar graph. Yes. Quantitative outcome. Yes. Quantitative outcome. Yes. Histogram. Categorical explanatory. Categorical explanatory. Yes. Categorical explanatory. It just has that. See, outcome, quantitative, categorical. Yes, yes, these two. And this one too. The other one is the only one is quantitative explanatory. How about the quantitative, quantitative? See? Quantitative and quantitative. We haven't explained that one. Okay. Quantitative and quantitative. How about the quantitative and see, categorical? Quantitative, explanatory, and this one. These two, mainly these two we haven't explained. Okay. But here's a quantitative, explanatory variable. Okay. So which is the best visualization for this one? Okay. Now what they're gonna do? Look at what they were doing. Look at this. This is the beginning of the regression. Now they say, so we have considered both quantitative thumb and categorical weight loss. They both are outcomes. Okay, they both gonna go to y-axis. Can you remember? They both gonna go to y-axis, not to draw the don't get confused over here. If you draw the graph, they both gonna go to x-axis for the sake of drawing the graph. For this one, we're going to draw the graph. Since it's a quantitative, we're going to draw a histogram. For this guy, we're going to draw a bar graph. When you're going to draw those, you definitely have to those per variable to go to the x-axis. And for in that graph, y-axis will carry the count, which is called the frequency. But when you do some kind of explained by this one, look at now we are heading towards a different setting. That this is what I'm talking about, not the graph. I talk about this one in the beginning. This one I'm talking about now, going back and forth. This is for the sake of drawing graph. When we have a quantitative variable, which is thumb length, being explained by the gender, you draw stack histogram, facet histogram, and facet histogram horizontally and vertically. Now I'm telling that just go ahead and then look at this one, say quantitative variable being explained by a categorical variable. Then you are trying to build up something called a statistical procedure called the regression, group regression. That's a different thing. That's what they are trying to do over here. Okay, look at for this one. Okay, there's a second based on the second example. On the other hand, I told that if you have this categorical outcome, see, being explained by a categorical some kind of a that explanatory variable, x variable. See, this is going to go to x. It's categorical. This one category. Like this going to be the condition. Condition. Okay, not the gender. For this particular second example, condition, whether they've been informed or not. For the categorical, we got again for the outcome weight lost or not. If that's like some kind of a statistical procedure, you're going to utilize this for the chi-square test. You can use a chi-square test. Now they will say that even for them, you can build up on some kind of a model. See, look at what they were doing. They were trying to explain, see, weight lost through condition plus other stuff. Where this other stuff coming from? Later on, you're going to see this other stuff would be the error. Okay, error. See, what is the best visualization to use? If you have a outcome variable, categorical, explanatory variable, categorical, graphical wise, not this process wise. Graphically, if you want to do that one, categorical and categorical, you use what? Bar graph, no? You use over here, can you remember? Bar graph. Here you use the histogram, see? Facet grid bar graph, facet grid vertically and horizontally bar graph. For the other one, quantitative and categorical, this one we use the histogram. By looking at this condition, you know you're gonna write for the y. This is y. See? This is x plus other stuff. If it is y, you know weight loss is categorical. You know this is x, it is condition, categorical, and categorical and categorical. If you're going to base visualize, you can use the tally, not the histogram for sure. Tally, you can use it. See? Tally, see? Look at the condition, categorical, categorical. You use the contingency table. This is called the contingency table. There's the same thing I showed over here in the next one. See? Contingency table. See? Contingency table. Informed, not informed. Weight lost, not weight lost. Like that. You can use the tally. What kind of outcome variable does it include? Categorical. See? What kind of explanatory variable it includes? Condition. Means categorical. Look at the other one. Now you go to the other connection. This is y. Y means like an outcome variable, term. Outcome variable, as I mentioned, always gonna go to y-axis, is y. So this connection is nothing but, if I write, okay, very clearly here, y equals x plus error. That means outcome variable equals explanatory variable, I'm going to say explanatory variable plus other stuff. Other stuff means error. That's the way how they explain. Doesn't matter what you're going to have for that outcome variable, whether it's a categorical or quantitative, there's a different discussion. We know how to. If you have like a graphically how to explain, not mathematically, not statistically. Graphically, you know, when we have like a outcome variable, categorical and categorical, you definitely go to the bar graph. See, bar graph. If it is explanatory variable, sorry, that this one is quantitative and this one is, so this one, see, these two, cat, see, I'm going to say this one, categorical and categorical. You go to bar graph. Bar means that's the facet grid bar graph. Okay. Then this one is, and this one. Then this one is categorical. This one is quantitative. Then you're going to go to facet grid, facet O, facet grid, for stack histogram. That's for these two, this is for these two. So example wise, if you get looking into this one, you can easily see that. First example you have, they put into that equation like that, weight lost. Weight lost. Plus condition and other stuff. Weight lost. So condition plus other stuff. Okay, I'm going to put OS for other stuff. So this is nothing but this is X plus other stuff. See? This is what? Categorical. This is what? Categorical. If it is categorical, you definitely have a bar graph. Stack bar graph, not step. Facet grid. So the next one is thumb length. It's a thumb length. This is example one. This is the one by gender. See, plus other stuff. This one is Y. This one is X plus other stuff. So this one is quantitative. This one is categorical. Then you're gonna have either stack or facet grid, histogram. You know all the commands. That's what they were saying here. In the second setting, you're definitely going to go to the visualization is done by the histogram. What type of histogram? Either stack or facet grid. Okay, not a regular histogram because I'm tackling two. Okay, it's not merely for that thumb. Okay, only it's thumb by or thumb across the gender. Okay, so histogram. What kind of outcome variable? You know the outcome variable. See? You know the outcome variable. Quantitative. See? Quantitative. What's the explanatory variable? X category. Another one, the height, and then now you're going to go to another set, third one, thumb and height. Okay, look at this one. Third one, I'm going to put thumb length being explained by the height and other stuff. This one is what? Y. This one is X plus other stuff. Or error, in another way we can call error. But this one is quantitative. This one also quantitative plus other stuff. What kind of a graph so far you learn in order to visualize that one? See? Neither. Tally? No. Histogram? No. Neither. Because they both. This being explained by another quantitative. You have to be careful. You cannot do anything. You can draw that one if they go standalone. Standalone means like a categorical. If it is categorical, you can draw the, I'm sorry, here. If it is a categorical variable, you can draw the bar graph for this guy, okay? Always for the Y, okay? Remember here, in this all three cases, your histogram, when I mention histogram, see, when I say weight lost equals to condition, you draw the bar graph for weight lost, okay? Remember that one. For Y, okay? Y. Pretty much similar way, stack for facet grid histogram for thumb length, which is Y. Okay. But the third case, quantitative and quantitative. You know the procedure, the statistical procedure is the regression based on that given this one, not the graphical one, this one. Okay. Quantitative means regression. Quantitative by the gender means a group regression like that. Okay, but you're not asking about that. They were asking about the graphical visualization. See? Neither can you see. You cannot do that. See? Right. No, nothing. What kind of outcome variable? Quantitative. Why? See? What kind of a explanatory variable? Again, see? Categorical. Sorry, quantitative answer. Yeah. In a summary, the key difference between the whether a histogram or tally will be more useful has to do with the type of outcome variable. That's right. We know, we explained that. If you wanted to explore a situation in which the explanatory variable is categorical, which of the following is true? Explanatory variable is categorical. A quantitative outcome variable would lead you to use a facet histogram. See, that's true. It's based on the quantitative outcome. Okay, outcome variable is the key part. Y is the key part. You draw the histogram for the Y, outcome variable, not for the explanatory variable. You can do that on standalone, but when they both come together, you're not going to draw the histogram for the explanatory variable. No. You draw that one for that one. Okay. Quantitative outcome variable would lead you to use a facet histogram. A categorical outcome variable would lead you to use a tally or bar graph. Okay, that's the idea. More ways to visualize the relationship. Point and jitter plots. Let's go further down and get another kind of a. See, now I'm gonna go ahead and then look what. See, quantitative variable is a gender. We had, you can remember, by gender for thumb we drew histogram. I'm gonna say no, I don't need the histogram. I'm looking into another type of, this is categorical. I'm sorry, this quantitative is categorical. See? Categorical. See? For this one, you don't do anything. You're gonna draw all the graph for this guy, Y, okay? You're gonna use now what? GF point. It has been done by the one shot. See, within the same graph. You don't have to. You don't need that the facet type. Like you're gonna have like a two separate the way that we had over here separately. You don't have to separate. This is gonna be done within, because you can draw histogram. Normally you can draw the histogram here and here, but that's not the way we did. We do the histogram within this framework and another frame within another framework. For the given another gender, we do that one. Now here, see, you don't need that pipe operator, see, to get a facet grid. See, and on the other hand, can we get the same thing with the facet grid? The same way this one, rather than doing this way, can we do the way that we used to do? What that means? What that means? This one. Okay. The jitter plot means like a scattering. See, within that one, you're gonna scatter rather than go see stacking. You're gonna scatter for a female and male. See, you're gonna scatter by this one. It's called jitter. See, same thing. But I wanna show you something. Then they can change the colors. See, and then they can get them very close, or then that just make it like a see contract, or that expand in horizontally or vertically. Okay, like that. See? And then they change the opacity. Opacity means like this brightness can be changed. Those things we're gonna discuss. And then on the other hand, the last one would be the quantitative versus quantitative, which is called the scatter plot. Okay, we are heading towards there. So by the time that we're done with here, we are pretty much cover all four categories. Okay, I'll show you. So this means, let's say I'm gonna get this one, okay, to go to the other side and try to do something here. Okay, you have this one, you have a stacked one, you have this one. Let's say that I really need to get this one and run this one and see whether this gonna work. See, thumb to y-axis, gender gonna go to x-axis, then the data. See, you saw this one, but I prefer to set this up the way that we did earlier. That what that means. Okay, I'm gonna get from here, otherwise it's gonna go away. Okay, so what that means that in previous in chapter 4, okay, and if you go to chapter 4, Cheetah plots, okay. Before that, facet grid, okay. And then a little bit early and get something and show you something. Okay, okay. No, not that one, not that one, this one. It's easy. Okay, I read that one and look at that. Okay, GF point, see, point, see, point being done for thumb only, data would be fingers, and that had been, see, I'm gonna cut this one and this way. It's a facet grid. See, it doesn't work. See? EF point cannot be drawn the way that we over here. Let's say that for the same thing, if I draw the histogram, that works. See? Yes, in that format. That means that you're going to draw the histogram first and then put that into two separated graph. Okay, we use on this one. But for the same thing, if you do for the bar graph, look at what happened. Bar graph. So you can see where the bar graph comes. It's a bar graph, but it doesn't make any sense. Okay, but if you do the point graph in this format, so you're gonna locate all the points by the gender. It doesn't work. That's why they're gonna put everything into just the same thing. The same. If you go to the next one, you can see that when you draw that see, point, there's no the linking or that pipe operator has not been utilized. You're gonna write y and x at the same time, but it's not the way we used to write that when you're gonna draw the facet histogram or stack histogram or like that. You just jig that one for that particular that variable, and then it's been expanded by the other variable. But here not like that. See, you're gonna draw everything within. See, within. Okay, remember that's the difference. You're gonna write thumb, tilde, say, then the fingers. You get this one. See, that's the. See? So they were stacking on each, and everybody's got all the data points. Each individual's thumb lengths for females and males. See, separate. Then you can change the color. See, you can change the size. How large this this dot should be. See, size. Size means that. See? You put the Y, thumb. You put the X. See, gender. You put the color, you put the size. See? If we compare the thumb length using the facet histogram, thumb appeared in what? Thumb appeared in what? Thumb appeared in x-axis. And the scatter plot that appeared in the y-axis. Remember, okay, what I'm doing. When you draw that one using the facet histogram, if you do that one, x gonna go to your. We draw the histogram for the desired one. If you want to draw that one, it has to go to x-axis. Here, the same thing gonna go to y-axis because the way that how that the type of that graph. Okay, see? Y-axis. But if you draw the histogram, it's gonna go here, and the gender gonna go this way or the other way by the facet grid. That's why they say here very clearly. The facet grid histogram. Faceted histogram or that those histograms you can get this thumb appeared on x-axis, but on this scatter plot or this point plot it's going to go to y. See? What does a point represent in a scatter plot? An observation units value. That means student thumb length and sex. They both, okay, they both thumb length and gender. Now what are you going to be with problem with the GF point, because they can't tell what point is on top of another point. We can jitter these points, see, scatter, okay, around little so that you can see all the individual points better. We'll use the function GF jitter to create a jitter plot depicting thumb length bisects. See, same thing. Instead of that, you put point, you put the jitter. See, for different genders. See, it's been scattered. Now they can see clearly how they've been scattered for within their groups. This one, see. Now you can change the color. See, orange, height. See, see, vertical jitter means vertically. See how they can be changed. See, we can play with the few arguments to modify the jitter plot. As always, we can use the argument color. We can also use the argument height to change the how points get jittered vertically. How they get jittered vertically. See, spread out a little bit up down. See, situation we might want the vertical jitter height to be set to 0 so that a point at 60 millimeter really is a person who has a thumb length 60. See? Thumb length 60 people easily seen. See? So they say to visualize very clearly. So height you're going to set to 0. See? Then the width, you can jitter them, see, horizontally. See? If you want to jitter them horizontally, see, not too much spread out this way. See, it's been restricted to 0.1. See, it's going to affect to both. Okay, both that with the width and the height. See, in a histogram, the height of the bar tells you how many people there are with the thumb length. In a jitter plot, what tells you how many people there are with the particular thumb length? How you're going to see? The count cannot be seen. You have to count by the dots. You have to count the dots. That's how they say, see, the number of dots in a row. See? Number of dots in a row. See? How many people? That means all this you have to count, all the dots. Very tedious, but it's gonna give you like a very nice and elegant graph. See? Now we do another modification. Then we're gonna do this one. See, just like a scatter plot, jitter plot, you can change the size of the points by including the size. See? Size you can change. Which means like how they've been jittered horizontally. This is jittered vertically. How much? You can also change the transparency, opacity of the point using the argument alpha. Alpha means that how opaque or that how clear this given dots. See, 0.2. We are using that now. That's the transparency. Opacity or transparency can be given. Jitter plot above which makes sure the transparency less transparent. You can do that. So they say they play around with the jitter plot. See, you can do that one. See, so this just pretty much if you do this one, you're gonna pretty much see the same thing again. Okay. Now what they're gonna do? Now that one was what? This one was that again. See, as I mentioned here in this graph, in this table. Now I have to add something to here. The way that I built up this discussion. I say that if you have like a outcome variable quantitative and this is categorical, you can do the stack histogram, faceted, okay, I think facet grid, vertically faceted histogram, stack histogram, vertical faceted histogram, horizontal faceted histogram, and we learn another one now. What? That the scatter plot. See, those are. I don't like to use the word scatter plot. I like to use the. This is one I'm gonna write here. Number 4. Point plots. Point plots. Again for y. Okay, you know that. For fifth one, jitter plots. See? So you can pretty much do 5 things for that. If you are doing some kind of a quantitative variable being explained by a categorical variable, you can do that one visually in 5 ways. By the stack histogram, not a regular histogram, has stack histogram, faceted vertical faceted histogram, horizontally faceted histogram, point, point, sorry, point plots, or jitter plots. 5 things. You learn that. And on the other hand, if you have a categorical variable for outcome and explanatory variable is categorical, you still can do 2 types of graphical representation. Those are like a faceted bar graph and faceted horizontal bar graph and faceted vertical bar graph. Okay? That one we discussed too. And all the codes are already available on this book. Okay, and during the discussion we had gone through that. Now what we're going to do? Now they go to see quantitative and quantitative. I'm here now. I'm here. Quantitative and quantitative. These are for the graphs. Okay, I'm going to put a name for this one on the top, the graphs. What kind of a graph you can draw if you have a quantitative and quantitative? That's what we call the scatter plot. See? Scatter plot. That's what we're going to see here very clearly. See? There's no any distinguishable that this one, that means for a given thumb length, and see, this one you can do, oh, sorry, not this one. Oh, I was, this one, I'm sorry, not this one. This one, that switch that one the other way around. Okay, jitter plots can be switched, and X and Y you can change and get the same thing. It's going to become next one. Not that one, sorry. See, plots together. Okay, before I'm going to go to that scatter plot, this category, okay. This one scatter plot, that's the one quantitative. We still here. Sorry, that this one in this one they just simply say that when you have, so this one quantitative, okay, not this one. Yeah, cheater plots. Yeah, here that's the same thing that been changed. See? They put this one thumb to here, X to the Y. You still can do that one. See, switching that one, it's going to come this way. But still, this one categorical, and it belongs to this one. Okay. Categorical and then categorical and quantitative. See, like that. Or quantitative and categorical. See, somewhere here, same kind of a setup. So this graph, we were talking about 5 graphs for this one, this situation. We talk about 2 graphs for this situation, and you can switch that X and Y. That's a different story. Okay, that's what they did over here. Okay, then see outcome to see if you are mostly going to put outcome variable on the y-axis. What order would you expand in our code? See, same thing. Outcome tilde explanatory. You know that. We talk about that one so many times. See, plot more plots. Then in addition to that one, you can go to another plot called the box plot. See, again, same thing. See, box plot. Now box plot, you did the point for GF point, you did the GF jitter, then you're not planning to do now the box plot for that thing. Again, quantitative and the being given through this one. Box plot is what? See, it's the box plot. See? That's another type. Then in the box plot, we mentioned about the box plot in the chapter 3 in a large scale. Box plot has like a whisker. See, let's say I'm going to go ahead and this one. This length, this bottom of the box will represent what? Quartile 1, Q1. This one represent the top of the box, represent quartile 3. This one represent this line in the middle or represents the quartile 2 or the median. This one, the top, at the end of the top whisker would be the maximum value. End of the bottom whisker would represent the minimum. Quartile 1, Q1, Q2, Q3, max will all together we call the pi number summary. We can remember that. We did that. Now they will add this one to the discussion between these 2 variables. The earlier part we had the discussion only for 1 variable that can be extended to 2 variables. You can remember in the box plot, you had this one, the box. You can get this done vertically or horizontally, but they prefer to do that. I'm talking about this one. This box plot can be drawn this way, see, horizontally or vertically. So at the end of the bottom whisker, you have the minimum. You have a minimum. At the end of the top whisker, you have the maximum value. And here, you're going to have what? Quartile 3. Here, you have quartile 1. In the somewhere here, quartile 2. This is something median. Median is very important. If the median is far away from the max, then is to the minimum. See this one. Then it's right skewed. If this is very close to this one and get far away from this mean, then it's going to be left skewed. If it is in the middle, it's going to be symmetric. We talk about those kind of like everything in chapter 3. So that's the same thing you can put this way. If you want, you can put the mean Q1 here, Q2 somewhere here, Q3 here, and max here. Those are called 5-number summary. See, 5-number summary. 5-number summary. So those are being graphically represented by the box plot. This is called the vertical box plot. This one, vertical box plot. Box plot. See, the box plot. This one, horizontal box plot. See? But they are using this one and having that variable on the y-axis. Okay, this time. Okay, so that the Q1, Q2, Q3 are called the quartiles. Those are the ones that going to divide that into 4 parts. See, so 4 parts. You have 4 parts. See? Up to here, 1 part, 2nd part, 3rd part, 4 parts. See, 4 parts, and those are the devices called. Those are the numbers that gonna separate that into 4 parts. So normally they call the quartiles for this one, and this one, and these are the devices, but they also call the quartiles for south and medians. And see that those are now can be done for using this command. See, and the dots. These dots are nothing but the outliers. This is outliers. If you see a dot here, it is not an outlier. These are outlier. Outlier. How to find the outlier? We had that discussion. Okay. The Q3 plus 1.5 IQR. IQR means this one, interquartile range. Interquartile range. This one. IQR. See, this gap, the height of the box, called the IQR, which is nothing but Q3 minus Q1. That's the height of the box, times 1.5 plus Q3 will give you the upper fence. Up to that point, all the data points are normal. Beyond that one, everything's going to be what? Unusual. So that means that in box plot, see, the box plot, this one, see, this one, see, from this one Q3, this one called the Q3 plus 1.5 times IQR, then you get this one. Pretty much the similar. This is the minimum. See, this is minimum. This is max. This is Q1. Then this length, this point is, I'm going to say Q1 minus 1.5 times IQR. Every data within this range is usual. Everything outside are called the outliers. Outliers, so unusual. Unusual. Outliers. This is max. This is the max. This is normally they call the fence. There's another fence. There's another fence like that. We're not going to go to that detail based on that. How they're going to talk about the outliers. How that highly risky outliers. See, those are those kind of a thing we built up. Next one, if you want up to this point, you can find out by the Q3 plus 2 times IQR. Like that. See, it goes like that. See. So anything between this one is like a different kind of outliers. Between these two, different kind of outliers, like that. Okay. But we normally go to this one. That's enough. See? We don't have to worry about this one. See? So those things now then we can do. So again, see. So I'm gonna go ahead and then add this one to even that table and say, hey, for this discussion, I'm gonna add another table. See, the 5th one, 6th one now. 6th one would be the box plot. If you draw some kind of a graphical representation for a quantitative variable by sixth one, I'm going to put here box plot. See, box plot. See, box plot. That's the sixth one. See, quantitative variable. If it is your outcome is quantitative and your explanatory variable is categorical, then you can draw even the box plot. 6 types of plots can be done. See, whatever you put for the y, then this is by x. See, very easy. We're going to show like this, and you can change the colors. See, outline and the dots. See, it's a very standard way of doing that. Now you can find the pi number summary. Pi number summary meaning Q1, Q2, Q3 like that. In addition to that one, you can look into all the statistics, favorite statistics. If you put the summary, you can simply get pretty much the same thing. See, that's why they say that in a box plot, you can remember what these are. See, number one, see, this one. So this should stop over here. This is not the max here. The max for female. No, it should be the. I think that they made a mistake here. The dots are always the outliers, but what they're gonna do, what they are doing over here, they just, because the whisk are gonna stop here. See, I think it's not the right. See? Can you remember the max for females? See? Max for females, it should not be this one. It should be here. Why they're gonna stop the whisker here? See? So that one, the whisker gonna stop over here. But they take this one as like a maximum point, but it's gonna, the way that they've been given over here, this one, since you have a dots, the furthest dot, not an outlier, okay, not an outlier. So this is what I mean, that in my box plot I didn't put the dots. If you see the dots, but the previous one, this one, I'm gonna get back to this one here. See this. If there are no dots, the way that I draw on my this one, I didn't have a dots, okay. Because of that, the end of whisker, talking about this one. See, that's why no dots, okay. So this gonna be your, see, this gonna be your max because since no dots. See, but if you have a dots here, see, dot appear in the bar graph, the maximum would be this one, but you're gonna count from here and then see what are the outliers, okay? Outliers. So this way, this is gonna be the mean, but these are outliers. They don't fall into that one. See? You can remember that. See? So they say, okay, this, see? So this one Q3, see? That's the Q3 for female. That's a median for females. It's a Q1 for females. So this one, see, minimum for females. They're pretty much the same way. Max for males, Q1 for males, Q3 for males, median for males, Q1 for males. See this one. There are no dots. See, no dots. See, minimum for female. If there are no dots, you're gonna consider the end of the whisker is the minimum. See, end of the whisker is the minimum. See, here, see, we still have this one. Okay. So this is the minimum for females, see? But it's not considered as an outlier. It's not considered an outlier. So this one would be what then? This height would be what? Can you remember? This height, if you have a dot, this height, what is that height? So can you remember that when we're talking about the box plot? Okay, I'm gonna go to chapter 3 over here, a little bit explain that one. If you have any doubts on that one, okay, box plot. Okay, I'm gonna go to number chapter 3, box plot one. Box plot, box plot. Okay, this is good. Yeah, I think this is good. No dots. So now the dots gonna appear, start appearing. See, it's not clear. Okay, now what we're gonna do? Little bit. See, let's go to this one. See, this means see this one. See, gather depth. It says clearly here. I'm gonna show that one. No, not that one. The previous page, under that box plot. Okay. Okay. Here. See here. The points that appear on a box plot are the outliers. If they appear above the top whisker, they are outliers because R has checked whether these values are greater than the Q3 plus 1.5 times IQR. If they appear below the bottom whisker, they are outliers because their values are smaller than Q1 minus this one. When there are outliers, the end of the whisker depicts the max or mean value that is not considered an outlier. See? When there are outliers, the end of the whisker depicts the max or mean value that is not considered an outlier. See? So if you see this one, see this is the minimum. But if you see the dots and the top one, the last one, at the end of that that one, at the end of see, when they are outliers, the end of the whisker depicts the max or mean value that is not considered an outlier. The end of the whisker depicts the max or mean. Sorry, it's not. Mistake. When there are outliers, the end of the whisker depicts the max or mean value that is not considered an outlier. Outliers. They say the points that appear on a box plot are outliers. The points are outliers for sure. But if there are outliers, this should be the way that they have taken is a discrepancy. Okay. See? But that's not the right way. There's some kind of discrepancy over here. Let me double check again. When there are outliers, the end of the whisker depicts the max or mean value that is not considered an outlier. There are outliers. Then they say the points that appear on box plot are outliers. Above the top whisker, they are outliers because R has checked whether the values are greater than Q3. See? So it has been, see, that means that the way that they explain, either this place is right or the other one wrong, or the other one wrong, this is right. Okay, they say this is maximum. They say that this been already checked for that whether there's going to be outliers or not. By doing what? They have added 1.5 times this length, okay, that length plus Q3 to see these values. See that means it's going to start from here. See, that's the fence. This is the fence, somewhere here, or above, or below. But it's not the max. Or sometimes, is the outlier going to come down max? Sometimes. The maximum going to go up. Okay? It depends on the way that how the data being given. See? That here, see? Look at. See? This length is so small. So small in that if you're going to start that 1.5 by this one plus this one, this length, it's going to go and then pretty much consider everything as outliers. See? Wow, this strange looking box plot, you can hardly see the box. It is squashed, see? Down on the bottom. And all these points are even, see? Now, see? Now so many outliers. See? So what they did was that when we see the outliers, they took the whole thing out, all the outliers, and then they're gonna draw that one for the rest for the filtered data. See, that's what they did over here. Filtered data. See? Only for the small countries. See? Now the small country means population small. See? Countries. Some extremely that see some outliers over here. If you can check that one with the histogram. Histogram shows that very clearly. See? Population. See? Extremely large population in so many days. This one. These extreme values were cut off. Then you're gonna get that this kind of a graph, but still it's not continuous. But doesn't matter. But at least you have taken out that highly populated countries. See, then draw that one, but still, see, that's why they say, see, wait, didn't we just exclude the outliers? See, we change the outliers. Why are these outliers in the box above again? Because the distribution has a different Q3 and IQR. These outliers greater than now the new Q3 plus 1.5 QR. See, they still show that. But here they say that something. They say when there are outliers, the end of the whisker depicts the end of the whisker max or mean value that is not considered an outlier. See? So the whisker is the max and mean. If that's the case, see, if that's the case, there's an issue here. See? So what this would be then? I think they made a mistake here. The way that they've been given, this should be max. These are just simply outliers. So there are no out here. They say end of that one. That's it. It's the mean. It's an outlier. Sometime outlier is going to be somewhere here. Based on that, the way that we're going to detect, because we're going to say the outliers are appear 1.5. So based on this 1.5 times this one first Q3. Okay. I want to double check this one. I think this is something wrong somewhere. Little bit. It's not consistent. There's a consistency. There's no consistency. The big box with the thick, I'll get back to that one. Okay, I'll explain this one again either in another video or the next day or like that. Okay, but there's not consistent. The big box with the thick line depicts the data that fall between Q3 and Q1 cut points. That's right. The data fall between 75th percentile and 25th percentile. This is called the Q1, called the 25th percentile. So 50th percentile, 75th percentile, or Q1, Q2, quartile 1, quartile or percentile, doesn't matter. Pertile, if you talk about the quartile, it's going to be first quartile. If you're going to talk about the percentile, it's going to be 25th percentile. This one, quartile wise, is going to be second quartile. Percentile wise, is going to be 50th percentile. This is going to be third quartile, quartile wise. If it is like a quantile, percentile wise, it's going to be 75th percentile, like that. Okay, the middle 50% of the data points. That's the middle line. That's the median. They're the data that are in the second and third quartile. See, the big box with the thick line depicts. See, thick line depicts. That's the median. See, if we created a box plot and then chain a jitter plot onto it, what proportion of the points would fall inside the box? 50%, because it's a box plot. And then chain with like a jitter plot. See, this is what they were talking about. They will chain that one with a what? Jitter and box plot. We draw a box plot and it's been chained by jitter plot. And then see, they say jitter plot has this one. See? They say that show the, not the box only, show the data points as well. Now they were asking that how many data points definitely going to go inside this box plot. It's 50% definitely going to go out of the bit. See, he did that one, just not merely not the box only. See, not this one. They want to see the data point as well. Doesn't matter whether they're scattered that outliers or not. That they want to see all the points. They say that if you do like that, see, if you do like that, see what, how many data points going to go inside the box. See, like this. How do you do that one? This is the code. You draw the box plot, and then that would be chained by, see, jitter. That's it. You don't have to put anything here. But if you want to do some kind of modification, see, you can just do the modification by changing color, opacity, or the transparency, the size, and all kind of stuff. Now they say that in the box plot but jitter plot above, how many variables are depicted? Just two, thumb and six. See? That's it. So see, modify this code to depict the box plot for thumb length by job. See, box plot thumb length by job. See, if you do that one by job, see? Data, fingers, color, see, blah blah like that. You see, instead of job type, thumb length has been given by, and it's been jittered by. See, that means within the box plot that they're gonna be distributed. See, okay, because of this given that different colors. See? Oh, why is a male and female? Oh, what is this? Not working, part-time job. Oh, it has been then divided into. Oh, color has been, because they give the basic. It's been even scattered again within the not working. It has been, see, it has been, see, separated. Wow, what happened? So, sorry. See, not only one box, that it's been again, see, separated by gender inside. See, you can do like that. See, for the color, see, you can do like that. For the not working group, for the male and female, and all the data scatter plots, jitter plots, see? And part time. This one is a full time. See? If you want that this way, see, this graph, then you have to take this out. You know that one. You have to take this out. Okay. You have to take this out. Then you're gonna see what something like that. You can give the colors, okay. But if you put that one, see, that one, see, sorry. For that one, if you want to keep the this one, you can say color. You can make it change by what? Job. By job. No? Color equals that one. After by the color. Can you remember color? Oh, oh no, not the equal sign. The tilde. Color should be why it doesn't show. Why this doesn't show this one? That one we can get by the work. This legend. The colors we can change. Okay, this is okay. This is okay. Here, let's take this one. Equal sign. See. So without that one equal sign, it won't show that the legend. Okay, it's been again. If you need that this legend, see, shows like this. You need the equal sign. Okay, they give the default colors. Okay, And for the jitter plot, they've been scattered. See, and then we can little bit stop, and I see that what we have here. Yeah, this is the place they are now built in that the same way that we were talking about, that they are moving on to the regression, the same thing. See, then how could you gonna find a relationship between this? See, among the variables. See, that's a graphical representation done now. Now we're gonna do the statistics part. Outcome is given by explanatory. See, y versus x. See, y tilde x explanatory. See, we did the GF point, jitter one, box plot, and we did the within the box plot we did the jitter two. That means that I can add something to this one. In this discussion, we have that all the graphs that we can draw, that when you have a quantitative y variable and this one, the seventh one, I can say that you can do box plot and jitter together, box and jitter together. I can add that one too. So I would say that for this one, seventh one, box plot plus jitter plot. So 7 plots can be drawn when you have a y quantitative over this y variable, this outcome variable is quantitative, and your explanatory variable is categorical. See? Stack, faceted, vertical faceted, horizontal faceted, jitter, point, box plot, box and jitter together. It's very important. But starting from now on, they are trying to build up that model. That's what they are trying to do over here. That's why that's the same model we saw over here. The model is this. The model actually. This is the model. Sorry, this is the model. This is the model. This is the model. That is the model. Y equals x plus error. Y equals x plus error. How you're gonna enter into the program y variable tilde x variable like that. And plus other stuff means the error. When you're gonna measure that one, you're gonna make some errors. See? So that's why they say that when you have variation in data, some data, that variation can be explained, some variation cannot be explained. If it is explained, it's okay. If it is unexplained, you don't know where this really comes from. They are coming from the characteristics of the system. These are real. But the other one are induced by data collection. See? Because of that, you have unexplained. See? Now what? Now induced one may be due to the measurement of error, or sampling error, or mistakes. See? Look at how you're going to have a variation in data at the end of the day. Some variation you can explain, some variation you cannot explain. It's due to that characteristics of the data, the system is real. This one, see? Induced by the data collection. See? Some measurements error. They say that if you really want to find that heights, see, some variation of the height and unexplained part is that some when you're going to measure that measuring instrument has some kind of errors. See, where some errors coming from. See, when you take the sample, you had the errors. When you measure, you can have errors. Sometimes that you measure not properly. From that, you're supposed to go from from the sole to all the way to the top of the head, rather than that sometimes halfway through. Those are different kind of measurements error. Sampling error, when you pick the sample, that errors can occur because you are using that not the right sample. Some mistake when you're going to enter data, see, like that. See? Those everything that in starting from here that I can make like another video, and then I think we pretty much done. But I'm going to make another video tomorrow and then upload into the system, okay? The Blackboard. In that way, pretty much we are covering chapter 4. Because the next week, that 5 would be that extension of this one. Same thing, see? You're going to build up a simple model and we talk about that one, okay? See? Data model is one. So I'm gonna go ahead and stop over here. The rest I'm gonna just whatever that missed, I'm gonna put it to another video, make another session and then record it and then just upload into the Blackboard. Okay, tomorrow. So if you guys don't have any, do you guys have any questions, anything? Okay. If not, I'm gonna wind up over here. Then I'm gonna tell you that good night, and then stay safe, and then be well, and then see you guys on next week, next Monday. If you have any question or anything, please email me or anything. It's about the test homework 2 and then midterm test. If you have anything, if you need one-on-one session or something, just let me know. Okay. Yeah. Yeah, thank you very much. Okay, thank you. Good night. Okay, thank you very much. Okay, thank you. Good night.
Thank you.
Thank you. Have a good night. Take care. Bye.
Bye.